So one of these ways that we could show or demonstrate that this is a linear relation is to rewrite the equation as y equals to mx plus b. When we rewrite this equation, we can see that the c takes place of the y value, the 15 takes place of the m value or the slope, the n is the x, and the 550 takes place of the b value. So we really have a y equals mx plus b equation. The next thing to do to prove that this relationship is linear is that we can create a table of values where the n value would represent the x input, since the number of people is the independent variable. And then, of course, the c would represent the y, or the cost. So by placing those n values directly into the equations as we have highlighted here, we get the following outputs. So at 0, it's 550. At 1, it's 565. At 2, 580. At 3, 590. Then we're going to take first differences. So if we go between 550 and 65, that's 15. Oops, I wrote 16. It should be 15. 560 and 580 is also 15, and these are all positive. This is also 15. And this is also plus 15. And so what we see is that each one of these first differences are constant. And so that means that I'm going to write since first differences are constant, right? They're all 15. The function is linear. So this is another way to prove that this is a linear relation. Once we plot the values from the table of values and we graph them, we do see that we indeed get a straight line graph. Now I've marked each point from the table of values and what they represent on this graph, and I've highlighted them here in yellow so you could see, well, what point refers to which table values. And so the number of people attending are going to be the independent variable because they're not dependent on the cost. But the cost, which is over here on the y-axis, is actually dependent on the number of people. So that is the dependent variable. But once we plot these points and then we see the straight line, it indeed shows us that this is a linear function or a linear relation. Now for part B of the question, the rate of change is defined in any function. I'm going to highlight that part here. Any function as the change in y values over the change in x. And in our context, that's the slope, right? Or the m value. So what we're going to do is we're going to go back to the original equation and figure out what the slope is. So when we go back to the original function and we agreed that this was the slope, the 15 right beside the n value really was the rate of change. And what that rate of change represented was that every time there was a person that was attending the hall, that the cost was going to be affected by a factor of 15. Now, most probably it's going to be affected by a factor of 15 because as more people need to be accommodated for, the room size probably has to be bigger.